So here's an application from physics known as Hooke's law. If you've got a spring, let's say that this is the ground, and the spring, beautiful, and this spring is 3 feet tall, then the amount of force required to compress this spring, so I'll just use F for that, is directly proportional, so it's equal to a constant times whatever comes next. And that's the distance that the spring was compressed. So I'll just use a capital F for force and a D for the distance that it was compressed. And now we need to find out about this particular spring. It takes 12 pounds of force to compress it from its natural length of 3 feet to 2 feet. So that means that it's been compressed by 1 foot as it goes from 3 to 2 feet. So the distance that it was compressed is a 1, and so that of course tells us that K is equal to 12. So from now on for this particular spring we can always use the force is equal to 12 times the distance. And now the question goes on to say how much force is it going to take to compress it down to 1 foot. So if we're compressing a 3-foot spring down to only 1 foot, then we've compressed it a distance of 2 feet. So the D is going to be at 2. So it's going to be 24 for the force, and in here the force is measured in pounds. So it's going to take 24 pounds. So if you put a small child on this spring, that would compress it down by 2 feet. Don't let go of that child. And then just out of curiosity, what if you got a bigger child? That weighed 36 pounds. So we would have 36 equals 12 times D, and solving for D we get the distance is 3 feet. So if you took 36 pounds and put it on this spring, you'd smash it right to the ground. Just for extra fun.